Hello, this is Ms. DB, and in this lesson we're going to talk about spheres. We're going to find both the volume of a sphere and the surface area of a sphere, and this is from Chapter 10, Section 8, the last section in this chapter. There is some vocabulary about spheres. You need to know what the center of a sphere is, the radius, a hemisphere, and a great circle. So here's a diagram of a sphere. A sphere is a ball. And a hemisphere is if you cut that in half. The great circle is the circle that would form the circle that would be the base of that hemisphere. That's called a great circle. It's the biggest circle that you could make on a sphere. The center is right there. It's the middle of the ball. And the radius goes from the center of the ball to the edge, or the center of the sphere. So there is, there's infinite places where you can make that radius, but there's only one center. The hemisphere, you would have, it's exactly half of that sphere. Now, sometimes when you're finding the surface area, you might be including that circle. If they call it a closed hemisphere, then you would have that filled in with the circle and need to find that. Sometimes it's hollow, like a cup, and then you would only need the surface area of the other part, the lateral surface area. So hemisphere is going to be half. Whether you're finding the volume of a hemisphere or the surface area of a hemisphere, it would be half of the surface area or the volume of the whole sphere. The volume of a sphere is given by a formula, 4/3 pi r cubed. So this is the first time that we've cubed our radius. You will cube the radius, that means times with an exponent of 3, so r times r times r, times pi times 4/3. So if you're leaving it in terms of pi, you would be multiplying 4 times, you can do it this way too. Some people write the formula like this, 4 times r cubed. You can divide it by 3, and then whatever that is times pi. If you're leaving your answer in terms of pi, this is the part you'll be doing with your numbers. You'll be plugging in whatever r is, cubing it, multiplying by 4, and then dividing by 3. So that's an alternate form of the formula. All right, so let's do this. Is that the radius? No, because it goes all the way across. So the first thing you would have to do is say, what is the radius? The radius would go from the center to the edge of your sphere, and that would be 12. You have to take half of the diameter. So that's the first thing you do. Then write down the formula, whichever form of the formula you prefer. I kind of like the other one, so I'm going to write 4 times pi divided by, I was going to do it different. I was going to write 4r cubed divided by 3 and then times pi. That way I'm leaving my answer in terms of pi by just figuring out the number part. So r is 12, so you're going to, where did they get 6? That's a mistake that I did not catch. So we're going to take and cube r, where's my calculator? I don't know what 12 cubed is off the top of my head, but it's a big number. So 12 to the 3rd power is 1,728. So off to the side here, I'm going to do my own version here. So I'd have 4 times 1,728, and I'm going to multiply that by 4, and then I'll divide it by 3, and then that times pi. So now I'm going to take 1,728 times 4, and I get 6,912, and I still have to divide that by 3, and I get 2,304 pi. That's my volume. This is volume, so you will have a cube on your unit. This is inches cubed. Now they used a slightly different form of the formula, and they got the same answer. And if it says to leave it in terms of pi, there's no sense in multiplying that by pi. If you do, just as I said in the last lesson, make sure you use the pi button on your calculator. So where's my pi button? Do not use 3.14 because the pi button on your calculator is a lot more accurate, and you're multiplying that number by 2,304. So if I use the pi button, I get 7,238.229474 inches cubed. If I use 3.14, I would get 7,234, which is a difference of 4. So you want to use the most accurate method that you can, and since you're using a scientific calculator or a graphing calculator that has a pi button, use it. All right, now this time they're looking for the diameter and they're giving us the volume. Write down the formula. Whichever form of the formula you like better, this one's just fine. Now there's no formula for diameter. It's radius. So we're going to go ahead and find the radius first, and then we'll just double it to find the diameter. So the volume we know, we're given that, so we put that in for V. We don't know anything on the right side, but there's already a 4/3 pi, so that's pretty good. Now, if you have pi on both sides, you can divide both sides by pi, and it cancels out on both sides. Now, if you want to get rid of the 4/3, because we want to solve for r, you could divide both sides by 4/3, but that's the same thing as multiplying by 3/4. So really, we're going to multiply both sides by 3/4, because then the 3 and the 4 cancel, and we're left with something equals r cubed, which is exactly what we wanted. Now, when you multiply 3/4 times 36,000, you can do that in your calculator if you want. You can also cancel. You can say, well, let's see, 4 goes into 36 9 times, so I have 9,000 times 3. So that's 27,000 is equal to r cubed. I'll erase mine since they got the exact same thing. Now, how do I solve for r if r cubed is equal to 27,000? The answer is that you take the cubed root. The cubed root. On doing something cubed is the cubed root. You take the cubed root of both sides, and the cubed root of 27,000 is 30. Now, you want to know how to do that on your calculator? You can just think about it. You could think, what cubed equals 27,000? But that might take you a while. On your calculator, I don't have a button for cubed root, but I do have a button for exponents, right? Mine looks like that. Sometimes it looks like x to the y or y to the x. I think usually it's x to the y. So you find your button for exponent. The cubed root is equal of, let's call it x, is equal to x to the 1/3. So you can take the cubed root of 27,000 by taking it to the power of, and then I'm going to use parentheses, 1 divided by 3. So here's what I typed into my calculator. I typed in, I have a TI-84. I typed in 27,000, and then I typed in my exponent key, and then I typed in the parentheses key, the first part of the parentheses, that's a parentheses, and then I typed in 1 divided by 3, and then I closed my parentheses, and I hit equals, and I got 30. Let me show you how it works on the little calculator that comes on my computer, because I can do it on here too. See, there's no cubed root button. Even if I go like this, there's no cubed root button. So what I'm oh yeah, there is. This is a cubed root button. You could use this. Let's see if that works. 27. I probably have that somewhere on my graphing calculator, but I wasn't sure where. I don't know how to do it on here. Well, that worked. So I went 27,000, and then I typed in the yth root, and then I have to type in what root? The 3rd root, cubic root. And then I get my answer. So that's one way to do it. Otherwise, I can go the way I was telling you before, you can go 27,000, I have to get back here, to the exponent of 1/3. 1 divided by 3. So there's 1/3, 0.3333333. So I have 27 to the 1/3 power is equal to 30. So you have two ways of doing it. Go back here. So anyway, we get 30 is equal to r. However, they didn't want 30. They didn't want the radius, I mean. They wanted the diameter. The diameter is twice the radius, so then it would be 60. All right, this one we want a volume of the hemisphere. The hemisphere is half of the whole sphere. So we are going to take the formula of the sphere, which is volume equals 4/3 pi r cubed, and we have to take half of that. Well, if I take half of 4/3, let me just squeeze in a 1/2 here. 1/2 of 4/3, the 2 goes into the 4 2 times, you get 2/3. Half of 4/3 is 2/3. So this is the formula for volume of a hemisphere. You can write that down in your notes if you want, or you could figure out the volume of the whole sphere and divide it by 2 when you're done. That would work as well. Or you could figure it out each time. So 2/3 times pi times 15 cubed. They don't tell us whether or not to leave our answer in terms of pi this time, but there's the answer in terms of pi. 15 cubed times 2 divided by 3 is how you would handle multiplying by 2/3. This time they want us to find a radius of a sphere with a volume of 2,304 pi. Write the formula down, plug in what we know, which this time is volume. Now we can cancel pi from both sides because it's multiplied by pi multiplied by pi. Then we will multiply both sides by the reciprocal of 4/3. And then we'll have r cubed. Now let's figure out what 2,304 is times 3/4. So on my calculator, I'm going to go 2,304 times 3. I get 6,912. And then I still have to divide that by 4. 1728. Now I'm not sure what the cubed root of that is, but that's what I have to do next. I have to take the cubed root of that to find r. So I take the cubed root of 1728. Remember how we do that? You can either use if you have a cube root button, or if you have it looks like a square root button where you can actually change what root you're taking, or I can take that number to the 1/3 power, or you could just go 0.33333 as your exponent, and I get 12. And I can check it by going 12 to the 3rd power, which is indeed 1,728. That's just my check. So did they ask me for the radius? Yes, they did. So the radius is 12, and I'm all done with that problem. So sometimes you're looking for the volume, sometimes you'll be looking for like the radius or a diameter. Okay, surface area is next. Surface area formula is 4 pi r squared. So write your formula down, and then you're going to use it. So it's like 4 times the area of a circle. Find the surface area of a sphere with diameter of 76. Well, the only problem with that is that we don't want diameter, we want radius. We never really want diameter when we're looking for area. So you got your formula written down. You found that the radius is 38 by dividing 76 by 2, and then you just plug it in. If you're going to leave it in terms of pi, then you would just multiply, first take 38 squared, and then multiply that by 4, and you get 5,776 pi. This one asks us to find the volume if the surface area is 324 pi. Now this is a multi-step problem. First thing that we have to do is think about what we're given and what we could find from that. So the formula for surface area is 4 pi r squared. We just learned that. If we know the surface area, then we could find the radius. And that's what we're going to do first. So we'll plug in what we know from the surface area. 324 pi equals 4 pi r squared. Now we can cancel the pi on both sides and then divide by 4. And that will give us r squared. I think they skipped a couple steps there. So if you take 324 on your calculator, divide by 4, you get 81. So 81 is equal to r squared, and then they took the square root of both sides to get r equals 9. That's how they got r. Now that we know r, it becomes a different question. It becomes, what is the volume of a sphere with a radius of 9? So then it's just a matter of plugging 9 into your formula, cubing it, multiplying by 4, dividing by 3. Remember, the alternate form of the equation is 4 times r cubed divided by 3, and then multiply that by pi. So if you're leaving it in terms of pi, you can use that alternate form, which is just rearranging a little bit. And we get 972 pi. That's our final answer. inches squared, because surface area is squared again. Now this one gives us the area of the great circle. The great circle is the one that is in between the two hemispheres. And if we know the area, then we could find out the radius of the great circle, and the radius of the great circle is equal to the radius of the sphere. So it's the same r. So what we'll do is we'll set up the formula for area of a circle. Area equals pi r squared. Then we'll plug in what they told us the area is, which is 49 pi. Plug that in for a. Cancel our pi's, and then it's just a matter of taking the square root of both sides to get 7 for our radius. Square root of 49 is 7. Now that we know what r is, we'll use the formula for surface area of a sphere. Plug in that r is 7, and 49 times 4 is 196, so 196 pi miles squared is the surface area of the sphere. In this example, we're given the diameter. Do we want the diameter? No. So the first thing you have to do is take half of the diameter to get that the radius is equal to 25. Don't forget to do that. Then we use our formula, which is 4 pi times the radius squared. We have to square 25, which is 625. Multiply 625 times 4 to get 2,500 pi. And that's it. Okay, the effects of changing dimensions. You have to know, because this section is the only one that is on both volume and surface area. So it's very important that you look at what do they want. Do they want you to describe how it would be affected, how the volume would be affected, or how the surface area is affected? So, surface area and area, just plain old area, is the same. If you are increasing your dimension, if you're increasing your dimension by x, the surface area will increase by x squared. And the volume will increase by that amount cubed to the third power. So if the dimension increases by x, the surface area increases by x squared, the volume increases by x cubed. You don't actually have to find the volume of the original and the new, or the surface area of the original and the new. You can, and you should find the same thing, but sometimes it's a little complicated to be able to find that from these kind of complicated looking answers that they have. So if the radius of the sphere is multiplied by 3/4, and we're looking for volume, then we look at the chart. Oh, it should be cubed. So I'm going to cube 3 cubed over 4 cubed. So 3 cubed is 27, 3 times 3 times 3. 4 cubed is 4 times 4 is 16 times 4 is 64. So the answer for this is that the volume would increase. I'm just going to double check my, yeah, that's right. The volume would increase by 27 over 64. Okay, this time they want to know what is the change on its surface area. It's being divided by 3. So you can go ahead and do all the work if you want, but remember that surface area will be that amount that your dimensions increased squared. So I have to square. If it's divided by 3, I need to square that, and my surface area will be divided by 9. 3 squared is 9. So here they did the work. This one we actually can see that if I divide that by 9, I would get that. So it's been divided by 9. Composite figures are the same as all the other ones we've done. They'll often be a hemisphere with a cylinder, or sometimes with a cone, because they're circular. And if you put a whole sphere on top of a cylinder, there's actually only going to be touching at one point. So usually they would have a hemisphere for these problems. So you find the volume. Is this volume or surface area? This is surface area. Remember that in surface area, you do not count the part where these two touch. You will not be counting this section right here. So we will, let's see, the surface area of the composite figure is the sum of the curved surface area of the hemisphere and the lateral area of the cylinder. and the base area of the cylinder. Now, when we did surface area of a sphere, we didn't have a separate part for, we had just a formula. So the surface area of a hemisphere is half of the surface area of the sphere. Okay? We don't need to worry about that circle, that closed-in circle. We don't have to add that to it because surface area of a sphere doesn't have any bases on it. It's just the outside of your ball, the wrapping you would cover that ball with. So we would just take 1/2 of 4 pi r squared, and then the radius is 6 because the diameter is 12. And that's the same as your radius of your hemisphere. So we get 72 pi. Then we have to figure out the surface area of the cylinder, which is they're just doing the lateral part of it. And then we also need the base of that cylinder, because we do need to include the bottom of this, which is a circle. So we have to have one base. And then we would add those 3 parts up to get a surface area of 216 pi. And you might have to look these up, but you should be working on your formula book for this chapter, and you should have these in there anyway. So if you don't, get them in there, and then you'll be able to just look at your formula book to see what you're missing. Now we also were asked to find the volume of this. The volume is given by just 2 parts. We need the volume of the cylinder and the volume of the hemisphere. So the volume of the hemisphere is half of the volume of the sphere, so 4/3 pi r cubed, but half of that is 2/3 pi 6 cubed, so we get 144 pi. The volume of the cylinder is the area of the base times the height, so pi r squared times h. So we end up with 324 pi. And then you just add those 2 numbers together and get 468 pi inches cubed. Sometimes you will subtract to find a composite figure. However, surface area of this one's kind of tricky because we do have to count the surface area of that, that hollowed out hemisphere. So the surface area is actually the surface area of the cylinder, the bottom and the lateral area, not the top, plus the surface area of this half sphere, this hemisphere. So we would take the surface area of the hemisphere, and we need to include that because it's like a hollow drum, you know, that would still be part of the surface area. And then we have to find the lateral area of the cylinder, and then the base of the cylinder is a circle. And then we will add all 3 of these parts together. So for surface area, even if something's being cut out, you have to include that area of where it's been cut out. Volume, though, we will be subtracting because we've got this cylinder and then we took out a big chunk of it. So in this one, we would subtract. First, we'd find the volume of the hemisphere. Then we'd find the volume of the cylinder. And then we would take the volume of the cylinder minus the volume of the hemisphere to get 27 pi cubic feet. So you can go back over this if you need to look at that again, but good luck, and please let me know if you have any questions, and I'll be happy to help you. Thank you very much.